Important part of any launch vehicle is rocket. The rocket works on the principle of Newton's third law of motion. Newton's third law of motion can be stated as for every action there is an equal and opposite reaction. Ejection of hot gases in downward direction causes action and motion of rocket in upward direction causes reaction. The law of conservation of linear momentum is also used in motion of a rocket. According to law of conservation of linear momentum, if the resultant external force acting on a system of interacting bodies is zero, then total linear momentum before collision is equals to total linear momentum after the collision of colliding bodies. On the basis of nature of fuel, rockets are divided into three types. They are liquid fuel rockets, solid fuel rockets, and liquid plus solid fuel rockets. Liquid fuel rocket, also called liquid propellant rocket. Important sections of liquid fuel rocket are liquid fuel chamber, liquid oxidizer chamber, pumps, combustion chamber, nozzle for ejecting hot gases, and the hot gases come out of the nozzle with high pressure. In case of liquid fuel rocket, hydrocarbons such as alcohol and kerosene often used as a liquid fuel. Liquid hydrogen is used as a fuel and liquid oxygen used as an oxidizer. Liquid hydrogen in short called as LH2 and liquid oxygen in short called as LO2. And many other combinations also possible, but nowadays majorly liquid hydrogen and liquid oxygens are used as liquid rocket fuel. Solid rockets or solid propellant rockets. In earlier days, gunpowder was used as a fuel in solid rockets. Another fuel called HTPB is used as a propellant in solid rockets. And one more fuel for solid rocket is aluminum powder mixed with oxygen along with ammonium perchlorate. Important section of solid rocket are solid fuel plus oxidizer. It is a chamber in which solid fuel plus oxidizer are present, a spark for ignition, and combustion chamber, and a nozzle to eject hot gases out of the rocket. Chandrayaan-3 mission has used three-stage rocket system. First stage rocket was powered by solid fuel. Second stage rocket was powered by liquid fuel. Third stage was powered by cryogenic engine, which is nothing but powered by liquid hydrogen and liquid oxygen. First stage consists of S200 solid motors called as step-on boosters containing HTPB. HTPB used as a solid fuel booster. Second stage, designated as L110, liquid fuel engine. It is designed in India, contains dimethyl hydrazine and nitrogen tetroxide. Third stage, designated as C-25, containing liquid oxygen and liquid hydrogen. They are denoted as LOX and LH2. Liquid oxygen and liquid hydrogen, when they come in contact with each other, they produce large amount of energy. We can say when liquid oxygen and liquid hydrogen come in contact, they cause explosion and produce large amount of energy. Now let us talk about working of rocket. The rocket works on the principle of action and reaction forces. The force of action is produced due to ejection of gases, smoke and flames from the nozzle of the rocket. The force of reaction due to ejection of gases, smoke and flames lifts the rocket and rocket moves in upward direction. Chandrayaan-3 was launched from Satish Dhawan Space Center in Sriharikota, Andhra Pradesh on 14th July 2023 at 2:35 p.m. It is lunar landing spacecraft. LVM-3 is a three-stage rocket system. It is heavy lift launch vehicle. For Chandrayaan mission, it is used fourth time. That means before using LVM-3 in Chandrayaan-3, it was already used 3 times before the Chandrayaan mission. Therefore, the name to this rocket given as LVM-3M4. Chandrayaan mission is divided into 3 parts. Phase 1, Earth-centric phase. Phase 2, lunar transfer phase. And phase 3, moon-centric phase. Earth-centric phase can be divided into 3 stages. They are pre-launch stage, launch and ascending stage, earthbound maneuver stage. In lunar transfer phase, there is only one activity, that Chandrayaan-3 is changing its trajectory. Phase 2, the stage is transfer trajectory stage. Under the phase 3, that is moon-centric phase. There are the different stages, and these stages are lunar orbit stage, moon-bound maneuver stage, separation of lunar module, boost and landing stage, lander and rover stage, moon-centric normal orbit stage. Now, let us talk about sequence of flight stages. The first stage, S-200 step-on boosters, STPB solid fuel at altitude of 0.024 km, and the journey starts here, therefore time equals to 0 seconds. And in the second stage, we got here L110 ignition occurs and altitude 44.6 km and flight time 108 seconds. After that, S-200 separation at altitude of 62.1 km, flight time 127 seconds. After that, L110 burning starts. After that, PLF separation at altitude of 114.8 kilometers, flight time 194.9 seconds. And after this stage, L110 separation occurs at the altitude of 175.3 kilometers and flight time is 305.5 seconds. And after that, third stage C25 ignition, altitude 176.5 kilometer and the flight time 307.8 seconds. After this stage, C25 is shut off and the satellite gets separated. So these are the different stages of launching and these are the sequence of stages, and at the end the satellite separation. Further the step is that the satellite start moving in the elliptical orbit around the Earth. Now talk about payload of Chandrayaan-3. Payload, it is kind of computerized, static or dynamic machine attached to the spacecraft, having devices such as transmitter, receiver, and perform storing and producing mission data and sending that data to the Earth. Payloads of Chandrayaan-3, there are two types. One is the lander payloads and second one rover payloads. Now lander payloads, first one is a RAMBA, full form is Radio Astronomy Moon-Bound Hypersensitive Ionosphere and Atmosphere. Second one is CHASTE, CHASTE, that is Chandra's Surface Thermophysical Experiment. ILSA, that is the Instrument for Lunar Seismic Activity. Now talk about rover payloads. First one is APXS, that is nothing but Alpha Particle X-ray Spectrometer. Second one LEAPS, Laser Induced Breakdown Spectroscope. Third one is a SHAPE, that is Spectropolarimetry of Habitable Planet Earth. Functions of RAMBA: to study the surface plasma density. Plasma density nothing but number of fuel ions per cubic meter. Measure the electron energy. Also measures variation of lunar surface plasma. Now second payload of lander is CHASTE. It will carry out the measurement of thermal properties of lunar surface near polar region. Now third lander payload is ILSA. Function of ILSA: to measure lunar seismicity around the landing site and will get all possible details of lunar crust and will get data what is inside the soil of the moon. The first payload of rover is APXS. It will study rocks, get chemical composition and mineralogical composition. It will find what type of elements present in the rocks and soil of lunar surface of moon. Now next payload of rover is LEAPS. Function of LEAPS are as follows: to find elemental composition of lunar soil and rocks near the lunar landing site by using laser spectroscope. The next rover payload is SHAPE. Function of SHAPE is this rover will study about habitability. It will find out can we human will able to live on moon in coming future. It will also find out availability of water and find proof for presence of life by using spectropolarimetry in near infrared wavelength range between 1 to 1.7 micrometer.